Great, you can make it to the crime scene so fast. As you can see to your right on the floor, this is where the professor was murdered. To solve this murder case quickly, we really need your forensic expertise and help. First, let me get you up to speed on what actually happened here. Our victim, a university professor, received a visit late last night. There's no signs of forced entry, which suggests it was someone he knew. It appears it was a struggle due to an argument for some reason. As it turned violent, the visitor struck the professor in the head with a heavy object. The visitor then walked away, bleeding from a wound of his own, leaving the professor for dead. We found the murderer's blood right here on the door. We have a prime suspect in this case already. If you can match this blood with the prime suspect, then we can prove he was here at the crime scene when the professor was murdered. Great, you got the evidence now. Looking forward to seeing your DNA analysis. Good luck in the lab.
Welcome to the virtual lab. I am your lab assistant for today. Click on me if you need my help. Let's have a look around the lab. When you look at an object, a description will show up. Turn to your right and look at the NGS machine. This is a next-generation sequencing machine. With it, you can sequence DNA just like scanning a building plan. Now look at the machine a bit further to the right. This is a transmission electron microscope. Both of these cutting-edge machines cost more than $100,000. In the virtual lab, you can use them as many times as you like without being afraid of breaking anything. Now finally, turn around to your left side. Behind this door, you will find the rest of the laboratory, where you can soon access many other virtual labs. But first, let's start with a little challenge. Look down to the left on the lab pad, and it will automatically slide up. Well done! The lab pad will boost your learning. Use it to answer quiz questions and access the relevant theory at any time. Now, look back at the table to hide your lab pad again. Congratulations! You now know how to use your lab pad. You can always look at it during the experiment to see what your next step is. You are now ready to solve the forensics case. First, let me show you what equipment we have on the bench. Have a look at the highlighted tube on the table in front of you. This tube contains the DNA that was isolated from the blood sample. Have a look at the lab pad to learn more about DNA. You can access the relevant theory whenever you want to learn more. Look at your workbench when you are ready to continue. The DNA is stored in the cell nucleus. When the cell is preparing for cell division, the DNA is condensed into chromosomes. The chromosomes consist of a complex of DNA and proteins. Like beads on a string, the DNA is tightly packed around histone proteins. The DNA itself is a double helix that consists of 2 strands. The DNA strands are made of building blocks called nucleotides that bind to their counterparts on the opposite strand. The box in front of you contains tubes for your experiment. Look at the box and click to open it. Well done! I have set up 2 machines for you. Take a look at the PCR machine to your right. The PCR machine can produce specific fragments of the DNA. The lengths of these fragments are unique for each person. Now, take a look at the e-gel on the left side of your workbench. This machine can be used to separate the DNA fragments and produce a genetic fingerprint. The police gave us the genetic fingerprint of the prime suspect, which you can see to the left of the e-gel machine. Our mission is to produce the genetic fingerprint with the DNA from the blood sample and then find out if it will match with the genetic fingerprint of the suspect. So now, let's get started with the experiment. First, we need a new PCR tube. Click on the purple bag to pick up a tube. Click on the tube rack to place the tube. Well done. In the lab, we use a pipette to transfer liquids. Pick up the pipette. Now click on the tip box to pick up a new pipette tip. Well done. Now click on the DNA sample and pick up the DNA solution. Put it into the PCR tube. Now you have to throw out the tip into the trash bin. Take a new tip again. Now we need to add the biomolecules that will help us copy specific regions of the DNA. Draw up the PCR master mix by clicking it. Now, add the mix to the PCR tube with your DNA sample. Awesome! You have now prepared your first PCR mix. Next, throw out the tip and put the pipette back. Then open the PCR machine. Pick up the PCR tube. Put the PCR tube into the machine. Great! Now go ahead and close the machine. Before we start the PCR machine, would you like to know more about how it works? Just nod your head if you'd like me to explain more, and shake your head if you would like to continue with the experiment. Great! I admire your enthusiasm. Have a look at your lab pad and click on the black box to watch an animation of the PCR reaction. The PCR reaction consists of different chemical processes that take place at specific temperatures. When the PCR machine heats up to 95 degrees Celsius, the DNA denatures and becomes single-stranded. After cooling down, the primers anneal specifically to the DNA, followed by the bonding of DNA polymerase. The polymerase is most active at 72 degrees Celsius and will copy the DNA. This process is repeated several times. During each of these cycles, the specific fragment, flanked by 2 primers, is duplicated. After 30 cycles, you will have more than 1 million fragments. The PCR reaction is completed. Okay, now press start to start the PCR reaction. Great, the machine is now running, and in the real world, this would normally take 1 full hour. But here in the virtual laboratory, we can of course speed up the whole process. I will now start a time warp. There we go. Time now runs 10 times faster than in the real life. See how the temperature is changing inside the machine every 30 seconds? Okay, let us now go inside the machine, into the tube, and see what is happening to the DNA on a molecular level. Get ready for an amazing experience. Let's slow down the time. Otherwise, we cannot see the molecules move around. The master mix contains the tiny building blocks of the DNA. In addition, there are the polymerase enzymes, molecular machines that can fuse these building blocks together to produce DNA. Look up! There is one just hovering over you. The polymerase uses an existing DNA strand as a template. To do so, it needs primers that are bound to the DNA template. The polymerase binds to the primer. It is ready to synthesize the DNA. There you go. The polymerase synthesizes DNA at an astonishing speed of several hundred building blocks per second. Soon the PCR machine will heat up to 95 degrees Celsius to separate the strands and start another cycle. Congratulations! You have now finished the PCR reaction, and the tube contains millions of copies of specific DNA fragments. Now we need to separate these strands according to their length. To do so, you have to load the PCR product into the e-gel. Take the pipette. Then put on a new tip. Very good. Next, pick up the PCR product from the tube. Now click on the e-gel. Load the PCR product in the gel by clicking one of the small wells. Now we need to apply an electric current to separate the DNA fragments. Click Start on the e-gel to start the process. This process will take about 1 hour too. Again, we can speed up the time here in the virtual lab. Let us fast forward. Now, let's compare the genetic fingerprint of the murderer with our suspect. Look at the genetic fingerprint from the police and compare it with the e-gel result. Do the two match? Click on the photo of the genetic fingerprint when you have finished comparing them. Wow, look at this. The pattern is exactly the same. It is the suspect's blood. Let's go to the court and present our findings.
We will now proceed with the jury's verdict. Who is the foreperson of the jury?
I am.
Has the jury reached a verdict?
Yes, Your Honor, we have.
Will the defendant please rise for sentencing? Will the foreperson please read the jury's verdict?
We, the jury, being duly impaneled and sworn, do hereby find that the overwhelming evidence, such as blood samples and DNA profiling, proves beyond reasonable doubt that the defendant committed the crime. We therefore find the defendant guilty in all charges and unanimously recommend the maximum sentence should be imposed.
The court, having heard the evidence, now finds the jury's verdict to be appropriate and fair to the defendant, the victim, and the community. The members of the jury have simply done their duty here tonight. Their decision is a group decision. Do not hold them responsible for your sentence. Members of the jury, attorneys, and court personnel, thank you for the respect that you've given the defendant and the law. You are excused. However, as you leave here tonight, remember you have a duty to uphold the oath of confidentiality concerning these proceedings.
Great work. Your DNA profile was really the prime evidence in this case. We couldn't have cracked this case without your great work, and I'd personally like to thank you on the behalf of the whole police department and the victim's family. We need more great and skilled people like you in our community. Keep up the great work, and I'll definitely call you again next time we get an important case like this.